Hey, how's it going? Good, good. Glad to hear that. Have you seen the last stats? We are approaching 30,000 active users daily in the United States. What I was telling you, YugaBulls is gonna be a big deal, huh? That's terrific. Congrats. Well done. But enough of the celebration. We've got a big problem to solve. Our database has become a bottleneck, right? It barely handles the current workloads. If we get another 30,000 active users next month, then we are doomed. Seriously. It will be just back to the 9 by 5 job for two of us. And I bet you don't want this to happen. So, what are the options, right? Yeah, I saw that you provisioned read replicas for Google Cloud SQL last night, and it helped a lot with read workloads. So, thanks for that. But it doesn't solve the problem with writes. If you remember, half of our users are buyers. They buy equities and stocks, and this is what kills our database. Okay, what are the other options? Correct, come on, we can schedule another maintenance window and upgrade the primary Google Cloud SQL to EVM with more CPUs and much better capacity. But come on, this cannot continue forever. It's getting harder and harder to pick a time window that would not impact our users. Just to remind you, our users are already all over the United States and some even users from Europe. Okay. What I'm saying, yeah, another database sounds like that's the best option. What are the options? Google Spanner and YugabyteDB. I love Spanner. I mean, it's wonderful distributed database, but in our case, it would mean, we have to rewrite a lot of the application logic. Don't want to go that path. It's too much. Yeah, YugabyteDB in contrast is based on PostgreSQL, which means that is of migration, but again, it doesn't scale writes, it scales on reads. We have to deal with writes. Remember, we need a database that scales both reads and writes. What are you saying, like YugabyteDB? I heard about them at one conference. Yep, you're right. They scale both reads and writes. Yep, seriously, they're based on the Postgres source code. Huh. And as scalable as Google Spanner. You know what? It sounds like a great match. Why don't we try it? Certainly, you want me to try this out. Okay, that's not a big deal. Let me provision YugabyteDB in our testing environment today, and I will try to migrate the application from Google Cloud SQL to YugabyteDB. Let's see how it goes. I mean, I'll ping you later today. Okay, deal, deal. If any other options, suggestions, give me a call. Cool. Bye now.
Alright folks, the time has come to upgrade our infrastructure. And as it's been said, we don't want to update the application logic. That's one of the most important requirements. The application was architected and designed for PostgreSQL, and preferably no any single line of code should be changed in YugaBulls fintech service. So, then, speaking about our horizontally scalable database, as it said, we decided to pick YugabyteDB, and I'm going to run YugabyteDB managed. That is available through cloud at yugabyte.com. I've already provisioned a multi-node cluster. Let me quickly show you what I've done. I added this cluster, I selected a dedicated deployment option. The cluster runs in GCP as well as the whole application. And when it comes to the deployment option, single region or multi-region, I went forward with the multi-region deployment option because in the future, I want YugaBulls to withstand any possible cloud outages within a region. All right. So my cluster right now has 3 nodes running, and that's more than enough for the current version of YugaBulls. One of the nodes is deployed in US West. The second node is running in US Central, and the last one is in the US East Zone. So once we switch our application to this multi-node cluster, you will see that reads and writes will be scaled by the database. And that's actually the bottleneck that the company is kind of challenging to solve with Google Cloud SQL. With Google Cloud SQL, they manage to scale reads with read replicas, but the read replica doesn't scale writes. And this is how YugabyteDB Manage can help us. All right, so the next step, that's our application. The application is live, it's running in production. It generates some traits, but it's still connected to the Google Cloud SQL. Okay, so what we have to do, we need to schedule a maintenance window. Let's say that it happened. And right now we are given some time to switch our application from Google Cloud SQL to YugabyteDB Managed. And we are stopping our application for the last time, just if you want to perform any infrastructure upgrades, because with YugabyteDB, you don't need to do that. If you need more resources, you can scale your cluster without any downtimes on the application side. Okay, the application is stopped. And I already have data, I already have schema. I want to import the data. I want to load this data in Yugabyte. I'm planning to take advantage of YugabyteDB Voyager. That's a special tool that was created for those who are migrating from PostgreSQL, MySQL, or Oracle DB to YugabyteDB. Okay, so let's do this. The first command, the first command will export the schema from my Google Cloud SQL instance. Let's copy and execute this command. All right, export it in this directory. So the next step is let's export data. Again, we will connect the tool YugabyteDB Voyager, will connect to Google Cloud SQL and import all the data. Sorry, export all the data, right? Okay, it will take some time to export this data. Let's wait. Okay, all is ready. So the next step is to right now apply this schema on the YugabyteDB Manage side and import all the data, load all the data into my multi-node database. Just to show you that my Yugabyte Cloud is empty right now, YugabyteDB Managed instance, let's go to the tables tab. Let's refresh just in case. You see, we don't have any tables. We just have resources provisioned for us. So the next command, again, YugabyteDB Voyager, we are going to import schema, and the tool will connect to one of the nodes in my cluster, and the tool will request that node to create the schema in that geo-distributed database instance. Okay, we are creating schema type, domain, sequences, and tables. Let's wait for some time. Okay, triggers, extensions, all is done. So the schema is created, and the next step is to load data. For that, we are using Yugabyte Voyager import data command, and we are going to load through the same instance. Okay, started. The tool detected that we need to import data for two tables, buyers and trades, and all the data. Okay, it's loaded. Let's quickly check that that's the case before we switch our application to YugabyteDB Managed. Again, the tables tab. Let's refresh it, and you can see that yes, I do have these tables, and also the application uses a materialized view. It also was imported from Google Cloud SQL. So as of now, it means that I can safely go ahead and stop my Google Cloud SQL instance. But before that, the last step, let's switch our application. So for the application, I've already created the properties file that will be used for that will connect the application to Yugabyte. So again, we also use standard Postgres driver because YugabyteDB is a Postgres compliant database. We are going to connect through this instance. My application is running in US Central Zone. That's why the shortest way for this application to get to the Yugabyte cluster is through this node that is also deployed in the US Central, and the password and some other information. So let's right now start my application. So I have this command for the application prepared. Again, the same logic, no any changes. And that's the new properties file. And we are going to print different statistics. In this case, as you see, we are not recreating the schema because the schema was imported. And we already have some traits. Certainly, the traits were imported as well from Google Cloud SQL with the help of YugabyteDB Voyager. Okay, and you see that within several minutes, we managed to migrate our YugaBulls fintech application from Google Cloud SQL to YugabyteDB managed. And for what? Why did we do that? We wanted to scale both reads and writes. Let's check that. Let's refresh this screen. And you can see that right now the application sends reads and it also updates the data. And every node takes part in processing my queries. And you can see that both reads and writes are scaled. That's what was not possible to achieve with Google Cloud SQL and read replicas. Okay, keep refreshing. Wonderful. We made it. We made it with no any code changes. That's the PostgreSQL compatibility in action. And right now you have a horizontally scalable database that spans multiple regions. And finally, as I said in the beginning of this demo, when I was stopping my application, when the application was connected to Google Cloud SQL, I said that that was the last time I'm scheduling a maintenance window to upgrade my infrastructure resources. Because with YugabyteDB managed, suppose that we want to get more nodes in our cluster. For instance, my traffic doubled in a month, so YugaBulls is becoming a much more used service. So what I do here, I'm just increasing the number of nodes and I'm scaling my cluster. And this will be done in parallel with no any impact on my application. So like while this infrastructure will be updated, my application will be running, the traits will be coming, and the traits will be inserted in my database. Wonderful, right? Okay, so what's going to happen next with our startup company and with our fintech service? You can see in the next episode. If that episode is not released yet, then you know what to do. Ring the bell and subscribe to this channel to get notified. Thanks. Bye-bye.